Good morning, girls. How are you? Okay, today we are completing the lesson that we started yesterday, lesson 16.1, in which we are talking about the segment length and midpoints. Yesterday I uploaded a video for you explaining what is the difference between a point, a line, and a plane. The point, line, and plane are the basic things that form a geometry. A point, as you can see, the dot, a line, which is like two dots connected together, and then a plane, which is like many dots in many dimensions or in many places, so they are creating a plane. And yesterday you had a question in here in which you are required to determine if each one of these 5 things are defined or undefined. I uploaded a page for you yesterday explaining that the undefined are the 3 basic things: the point, as the point doesn't have a name; a line, again, it doesn't have a name; and a plane, it doesn't have a name. That's why these 3 terms are the undefined terms. But for a segment and for a ray, the segment and the ray, they are a specific type of lines. You know what is segment and what's ray, right? A segment is when you are, like here, question B, when you are connecting 2 points together. But is there endpoints? Yes, there is. There are 2 endpoints at J and K. This is called a segment. This is called a line segment. What about the line in question A? This is called a straight line. When you have no ends at both ends, you are going to infinity at both ends. As you can see, I have an arrow here and I have an arrow there. So my line is extending in both ends. Oh, this is called a straight line. This is a straight line. This is called a line segment. What about here? Here you have one endpoint at K and then you are extending to infinity at J. When you have one endpoint and one arrow, this is called a ray. So a straight line, a line segment here, and here this is a ray. All these 3 things are like a specific type of line. That's why they are going to be defined. So the point is undefined. The line is undefined. A segment, which is a specific kind of line, this is called defined term. Array, again, it's another specific type, so it's again a defined. And then for the plane, there is no name for the plane, so it is undefined. Okay. For the next page, this is cancelled, page 777 and 778. We are starting right away in page 779. Okay, in page 779 we are using the distance formula that we took a hint about yesterday. As you can see in your books, this is page 779 again. In your books, he is telling you that the distance formula is as if I have 2 points, x2, y2 and x1, y1. To get to the distance between them, this is the formula that you are going to use. We already took this formula in grade 8. It's going to be a huge square root, and underneath it's going to be x2 minus x1 all square plus y2 minus y1 all square. And all of you did use this formula to solve page 774, so you are familiar with this formula. Let's see the example. Example 2. I'm going to do with you question A and question B to make sure you understand, and then you are going to do your turn by yourself and send me a picture, please. Let's read the question. Determine whether the given segments have the same length. First of all, can you see the picture here? This? All of these lines, are they ray? No, they are not ray. Are they a straight line? No, they are not a straight line because they have 2 endpoints. So they are what? They are segments. From C to D, it's a specific line, short line with both ends. So this is called a line segment, line segment, line segment, and line segment. So the question is, he is going to give you 2 line segments and ask you, do they have the same length? You understand, of course, that the word length is the same as the word distance. So to find the length of any segment, this means that I have to find the what? The distance. In question A, which is already solved, he is telling you AB and CD. He is asking about the segment AB and CD, and he is asking, do they have the same length? So what I'm going to do, I have to find the length of AB and the length of CD using the distance formula. Let's begin by AB. We are going to write the distance formula. The distance formula is a huge square root x2 minus x1 all square. Some of you forgot the square, by the way. Do not forget it, please. Plus y2 minus y1 all square. And you have to include the bracket underneath the square root. Starting with AB. AB line segment means what? Mean that it have two endpoints, A and B. So I have to find x2 and x1, y2 and y1 for A and B. Let's go back to the picture. A, you have a coordinate plane. What about the point A? Who can give me the coordinate of A and B? Of A and B, yes. It's very obvious. A, I have -4 in x and 4 in y. And for B, it's +1 and 2. Right? So let's write them here. يبقى for A, the coordinate of A is -4 and 4. And the coordinate of B is 1 and 2. x1, y1, x2, y2, and then use the formula. So A, B distance is going to be a huge square root, and then let's start. x2 minus x1, which mean 1, x2 minus x1 is again minus, so it's a 1 minus bracket -4, close the bracket and close the bigger bracket all square. Why did I put 1 minus minus? Because it's 1 x2 minus x1, which is already minus, so it's minus bracket -4 all square. Okay, plus y2 minus y1, which is 2 minus 4 y2 minus y1, 2 minus 4 all square. Underneath the square root, using your calculator, you will find that the answer will be square root of 29. You can find the answer using the calculator, because he's writing on the book it's square root of 29. Anyway, so according to the question, we found the length of AB. We are going to do the same for CD. Okay, let's again CD. So I have to find the coordinate of C and D. Going back here, where is CD? Yes, C, D. The coordinate of C is 2 and 3. What about D? 4 and -2. طبعا you remember that always I have to start with X, not Y. So putting here, my C is 2 and 3. My D is 4 and -2. And then applying the distance formula. So CD is square root of x2 minus x1, طبعا x1, y1, x2, y2. So applying the distance formula, 4 minus 2 all square plus -2 minus 3 all square. Putting this on the calculator, you will find that this is actually equal to, again, square root of 29. So the question, is the two segments equal? Yes, they are. So I can say that AB is actually equal to CD. So I solved the first example. You are, I think you will be able to do question B by yourself. In question B, you are asked to find EF and GH in the same way that I explained. EF and GH. E, I'm going to find the coordinate of E. Yes, it's, for example, here -3 and 2. And for F, it is -2 and -3. You are going to find the coordinate, and then you are going to use the distance formula, and then you are going to do the same thing for GH. H may be tricky for some girls. What is the coordinate of H? H is what here? H is 2 in x, 2 in x, because 1, 2, so it's 2 in x. But is there any y for it? Is it going up or down? No, so it is 0. So the coordinate of H is 2 and 0. Okay? So what's required from you is that you are going to do question. This is the classwork that you have to try to send it by 2 p.m. or a little bit later. The classwork will be page 779, question, of course, A is done, question B, and then page 780, your turn, which is question 7. Okay? No, sorry, question 8. Question 8. So this is my classwork. Page 779, question B, and page 780, question 8. Okay? Okay, you are going to do it. But for me, I'm going to explain now the next part, which is finding a midpoint. What is a midpoint? A midpoint of any line is what? A midpoint is a point that divides your line into two equal parts. Can you see PO? PO is a what? PO here is a line segment. Point M is exactly in the middle. So it is dividing PO into two parts exactly equal. For example, if this was 10 centimeter, if PO was 10 centimeter, M will be exactly at 5. So that PM is equal to 5 centimeter and MO is equal to 5 centimeter. So this is called a midpoint. What about this thing? A segment bisector. Let's draw it. For example, I have a line segment like this. And this was my midpoint, exactly in the middle, dividing it into two equal parts. The word that you have in the book, a segment bisector, because you are going to be hearing it a lot. What is a segment bisector? A segment bisector is any line passing through M. M is the midpoint, right? You know what is the word bisect? What is a bisect? Bisect means dividing line into two equal parts. Into two equal parts. This is a bisect. So bisect means I'm dividing my line into two equal parts. So what is a segment bisector? A segment bisector is when you have a segment. Oh, this is a segment. And my midpoint is exactly in the middle. I'm dividing my line into two equal parts. Segment bisector is when you have a straight line or you have a line which is passing through this point. A line, a ray, a straight line, anything passing through here. يعني for example, I will draw this. I draw what? I draw a straight line. This is a straight line with arrows at both ends. This is a straight line. This line in this case is called a segment bisector because it is passing through the midpoint, so it is bisecting the segment into two equal parts. So whenever you have a line segment and you have a midpoint and you suddenly find a line passing through this midpoint, this line is going to be called a what? A segment bisector. Why? Because it is bisecting and dividing my line into two equal parts. This line is dividing this line into two equal parts. So segment bisector, let's call it. For example, if this line is L and this was PO as the one you have in the book. So the segment bisector is L as it is dividing PO into two equal parts. Okay? Okay. Going to the next page. Page 781 is cancelled. The thing of the paper folding, since we are not in the on the classroom, so I'm not able to do it with you. So anyway, we are jumping right away into page 782. Explain 4 right away. I'm going to explain with you question A, and then you are going to do B and your turn by yourself. And again, I'm going to upload for you another video in addition to this, the Professor Berger video, okay? Let's read it. Finding a midpoint on the coordinate plane. This is the midpoint formula. To find the midpoint of any line, again, any line segment have two ends, right? So the first end is x1, y1. The second end is x2, y2. To find the midpoint, point means what? Point means any point is x and y. So to find a midpoint, it means that I need to find its x and its y. To find its x and its y, the x is going to be x1 plus x2 divided by 2. And then the midpoint, the y value is going to be y1 plus y2 divided by 2. Yani, in other words, to find the coordinate of your midpoint, you are going to use the coordinate of the two end points. Let's solve question A and see our answer. Take care, the question in this part is not going to be that direct. He is not going to be asking, find the midpoint of this line. You are in grade 9 now, so it's not that easy and it's not that obvious. Read the question. Show that each statement is true. And this is like a true or false statement. If PQ is a what? Whenever you have a line like this, it's a line. So this is a line segment. If PQ has endpoints P and Q, first of all, he gave me P and Q. So I'm going to extract the information. This is page 781. Sorry, 782. 782 is 781 is cancelled, we said. So this is 782. Question A. He gave me P and Q, so I'm extracting P and Q. P is -4 and 1. Q is 2 and -3. Okay? So if P and Q is whatever, then the midpoint M lies on quadrant 3. Yeah, forget about quadrant 3. He is telling you, so the midpoint M. Yep. So I have to find the midpoint M, right? I have to find the midpoint. Let's find the midpoint. Yeah, I'm trying to find the midpoint. We said that the midpoint should be x1 plus x2 by 2. All of them طبعا by 2. And here y1 plus y2 divided by 2. Here this is my x1, y1, this is my x2, and this is my y2. Applying them on the formula, so M is going to be -4 plus 2 divided by 2, 1 plus -3 divided by 2. Putting this on the calculator, please, when you are putting this on the calculator, because I am sure that some of you maybe do it wrong. You have to put this inside a bracket because all of this is divided by 2, not only this. So on the calculator, you are going to write bracket -4 plus 2 and then divide or over or whatever 2. Okay? You are going to find your answers using the calculator. The midpoint is going to be, let's use another page. The midpoint is going to be, after you find it, -1 and -1. I still have a very, very small part. The rest of the question that I told you to forget about it for now was, so the midpoint M lies in quadrant 3. What are the quadrants? How many quadrants we have on the coordinate plane? You remember? We have 4 quadrants. And we said before, this is quad 1. This is quad 2, this is quad 3, this is quad 4. In the question, he is telling you the midpoint that you find, which was -1 and -1, it lies in quadrant 3. Is this true or false? Let's see. When I have -1 and 1, if I'm trying to put this point on the coordinate plane, where it will be? -1 and -1 means that x is -1 and y is -1. Let's try to put it. X is -1, so I have to move here, and y is -1, so I have to move down. So it will be in a certain place in here, for example. Is it in quadrant 3? Yes, it is. So this statement is true. Okay? You understand now? So each time you are going to be required to find any midpoint, and then by understanding the quadrants that I have here, quad 1, quad 2, quad 3, quad 4, I'm going to try to put my midpoint. Yani for example, it's not here. If my midpoint was 2 and 3, where is 2 and 3? Let's try to put it. 2 and 3. 2, it's positive. So I should go right. 2. 3 is again positive. So move up or down, move up. So 2 and 3. So it's going to be here, for example, in quad 1. And so on. I hope you understand. So the rest of the classwork is going to be page 782, question B plus question 11 and 12. Okay? Thank you.